So the next example is a show that question, which is another prove it question, just like the one we did on the previous page. So show that cosine of 270 degrees plus b is equal to sine of b. So once again, we want to expand out this left-hand side. So it's a cosine, so it means I'm going to have cosines paired together and sines paired together, opposite sign in the middle. So this left-hand side can expand out to cosine 270 cosine b minus because opposite signs, sine 270 sine b. We want to prove that this is equal to sine of b. All right, so let's go through. Cosine of 270 is 0. All right, that's from the unit circle or from the graph of cosine, whichever you prefer. I actually like to think of the graph for these angles. So cosine of 270 is 0 times cosine of b. Sine of 270 is -1, and then just sine of b. All right, and then this first piece goes away. 0 times anything is 0. -1 turns into +1, and sine of b is equal to sine of b. Perfect. Looks great. That's how we do these problems. Like I said, there's a couple of them in your notes, so be sure that you kind of reference it. Have your formulas ready, and then make sure you get the left-hand side to look like the right-hand side. All right, this last one. This next one, the next two examples are very similar, so this is kind of the last one out of the miscellaneous group here. Find the exact value of sine of 5 pi over 12. I actually think the radians are a little bit harder than the degrees, which I don't really often say. So my biggest piece of advice, once again, is to break this up. 5 pi over 12, if you think about how you can get to 5 pi over 12, you could have 4 pi over 12 and 1 pi over 12, but that's not very helpful. You could have 3 pi over 12 and 2 pi over 12 when I add them together. Now, that looks promising, and the reason why is that 3 pi over 12 is pi over 4. That's a unit circle angle. And 2 pi over 12 is pi over 6. That's a unit circle angle. So what we're doing here is we're looking for unit circle angles in radians that I can get to 5 pi over 12. And so I just break it up the easy way first and just break it up with pi's over 12s, because that way we can reduce down. It's easier to do the addition. So 3 pi over 12 and 2 pi over 12 get me 5 pi over 12 when I add, and then those angles are unit circle angles. So sine of 5 pi over 12 is the same thing as writing sine of pi over 4 plus pi over 6. Okay, because I know that pi over 4 is the same as 3 pi over 12, and pi over 6 is the same as 2 pi over 12. All right, you expand it out, and you expand it out inside the parentheses. Very, very important. All right, so this is a sign addition, which means that we're going to alternate the trig functions, but we get to keep the sign SIGN in the problem. So if it's a plus in the problem, it's a plus in the expansion. So it's going to look something like this. Sine of pi over 4 cosine pi over 6. So swap the trig functions. Plus, because we're adding. And then it's going to look like sine pi over 6 cosine pi over 4. Wonderful. Sine of pi over 4, root 2 over 2. Cosine of pi over 6. Pi over 6 is 30 degrees. Cosine of 30 degrees is root 3 over 2. Sine of pi over 6, sine of 30 degrees is 1/2. Cosine of pi over 4 is root 2 over 2. We simplify, we condense. I'm going to just do this in one step now because I've explained it a couple times. This looks like root 6 plus root 2 over 4. All right. I hope you feel comfortable using these formulas. These are kind of the more basic problems in this section. We have 2 problems left. They are kind of intense, so I'm going to do them in a separate video. Make sure you follow along. Pause if you need to when I begin these next 2.